Have you ever had to go back to instructions for some task over and over again? Maybe there's some recipe that you absolutely love and you keep going back to make it. Well, sometimes a program will have to do something more than once. In fact, there may be things a computer will have to do millions of times. Unfortunately, it's not usually as fun as a recipe. Now, it can get tedious to write the same thing over and over, even just 10 times. It's slow, it's prone to errors, and it's really difficult to change. Luckily, repetition is so common that programs have a built-in solution called a loop. A loop is just an instruction that says, return here once you reach this point. A real-world example of this might be if you look at a shampoo bottle. Now, I've seen some that have these instructions on them. Wash, rinse, and repeat. So if you pretend to follow these instructions like a computer, you go through these one step at a time. First you wash, and then you rinse, and then you get to the repeat step. And that will tell you to go all the way back to step 1. And you do everything again. Wash, rinse, repeat. Over and over and over until you run out of shampoo. In the programming world, this is called an infinite loop, where a loop keeps going until something breaks. Now, this is where the topic of our last video, conditionals, comes into play. But let's go to a different example, because there's really no need to wash your hair more than once per shower. Instead, let's say we're making a table, and you get to the point where you need 4 legs. Well, this whole process can begin by asking the question, do I have 4 legs? And that is your conditional. If the answer is no, you need to make a leg. Now, it's important to note here that we still have to tell the computer exactly what to do in the order it needs to be done. So in order to make 1 leg, we need to first measure out the correct length, and then we can mark that measurement with a pen or a pencil. And once we've made that mark, we need to cut at that point with a saw or something. Then, once the leg is made, you can ask the question again of, do I have 4 legs? If the answer is no, you do all this again. If the answer is yes, you can go on to the next step. Now, it's important to note that this does not break anything that we've talked about so far. Everything still runs one step at a time in order. We're just redirecting the flow to go back to a specific point if needed. So why do loops matter in programming? Well, without loops, programs would be extremely limited. It would be so much more tedious to write a program, because everything that has to happen more than once would have to be written over and over again. And some things would even be impossible without loops. Loops are running constantly on your screen, updating the pixels on your display, checking for an input, or even allowing the animations in a video game to run. Loops are the only reason a computer can constantly check if a key has been pressed. The main point is this: loops allow a program to repeat behavior without having to write it over and over again. They let a program keep checking conditions, responding to input, and just generally running until it's time to stop. So with that, we've talked about the main parts of a program's flow. Run one task after another in order, be redirected by checking some conditions, and repeat sets of instructions through loops. But programs can still get messy. So in the next video, we'll talk about how programs organize and reuse logic through something called functions. Hope to see you in that video.